with by a chromate wash, which both increases the anti-corrosion performance and the adhesion of the next stage, the cathodic electrodeposition of paint.
The operator places 2 electrodes in the boot, just in case one gets snared up or falls off, to make the car a cathode.
In the tank is a monomer dispersed in an electrolyte. We'll consider it as a long-chain hydrocarbon with an amino group which becomes positively charged as it dissolves in acid. Apply the current and these cations migrate to the phosphate-coated metal.
There, the hydroxide ions produced neutralise the charge, leaving the first molecules to arrive to hydrogen bond with the phosphate. Eventually a film thickness of around 30 microns builds up, held tightly in the gaps between the crystals of the phosphate layer.
In other words, the paint is keyed onto the surface. Then the vehicle moves into an oven where some clever chemistry occurs.
First the paint monomer flows. This will eventually give the electrocoat its smooth, even finish. Then at about 160 degrees centigrade, isocyanate groups on the hydrocarbon chain become unblocked and free to react with the hydroxyl groups.
10 to 15 minutes at 175 degrees centigrade is all that it takes to make these chemical crosslinks and form the electrocoat polymer.
The car moves on to the next anti-corrosion process. At this stage, exposed metal joints are protected with a PVC-based sealant, as is the whole of the underside of the body, to provide a tough, impact-resistant layer.
A special anti-stone chip paint is also applied to vulnerable areas such as door edges and wheel arch rims, and again cured in an oven. Next, a primer surfacer paint is sprayed on to create a smooth finish. Then 2 coats of colour base coat and 2 coats of clear coat follow.
The total paint thickness, including the electrocoat, varies from 100 to 150 microns.
But we haven't finished with the corrosion protection yet.
Wax is injected into cavities which might trap water, in one of the last processes before the car moves on to the line where all the components are introduced and the interior fitted out.
When the gleaming product emerges on a production line like this, it's undergone many processes to protect it from corrosion.
And some of these link right back to the time when the car was nothing more than a few lines on a computer screen. That story really starts here with Rover's engineering design group at Swindon.
Their job is to translate the stylist's design ideas into pressed steel pieces that really work when fitted together.
Cut it around the rad, so that's about the limit of it. If we go any further, we'll start to affect the door inner flange.
Can we weld it?
Can we paint it?
Can we seal it?
Are there enough drainage holes in the body?
And where are the best places to position them? As the design evolves, and there are many changes in the evolution of a new car, prototypes are tested.
At Gaydon, the accelerated corrosion tests are important, and feedback about clearances, drainage holes and any area that might become a rust trap is presented to the design group for a rethink.
And then we duplicated the other holes, so you've got these 2 holes along the length of the door.
Right, that should be fine. Right.
Since the industry introduced warranties against corrosion, it's nice to think that they are making sure that clients will not need to worry about inherent rusting.
For the length of the warranty at least.